Hey, 8th grade. This is your independent work for today for math. You have this lesson, and then you have some Delta Math follow-up work. Today we're going to continue our work with proportional relationships. Okay, so I would get a highlighter ready. And we're just going to go through the first part. So what we've learned from lesson 1, we know that when two variables, say x and y, are proportional related, the following is true. So we can look at this down here in this box about proportional relationships and know this holds true, okay? So x over y equals a constant k. And I'm going to be referring to this constant k a lot. That is called the constant of proportionality. And we can also think of it as the unit rate that y is changed compared to x. So y is going to change depending on what x is. Okay, so we're going to be looking at some relationships today, and especially concentrating on speed. Well, that's after this first exercise. Focusing on speed to look at proportional weight relationships. Okay, so let's look at exercise 1. The weight of water is proportional to its volume. Okay, so most of your problems are going to say it's a proportional relationship. We know that 50 gallons of water weighs 417 pounds. Let V be the volume of water in gallons and W be the weight of the water in pounds. So the first thing we have to determine is what depends on what. Okay? So we know that the weight depends on V, or on the volume. All right, so V is going to be our x variable and W is our y. So the ratio of the weight of water to the volume. So the weight over the volume. If we go back to the problem, we know the weight is 417 pounds, which is written LBS, for every 50 gallons of water. So it asked me also to simplify the fraction, but I know that 417 does not divide equally by 5, by 10, by 25, or anything. So this is in its simplest form. Okay, so now that I know that W is my y and V is my x, I can go ahead and write an equation. So y is equal to, and this is my k. This fraction right here is my k. So y is equal to 417 over 50 times x. Or W is equal to 417 pounds over 50 gallons times the volume. Okay, so that's really, really important. That right there. So I'm going to go ahead and circle that. So we're going to use this for the next part of our problem. Oh, that's it. All right, so we're going to do another weight and volume function. So we determined already that our volume is x and our weight is y. So the weight depends on the volume. Okay? So is the ratio of weight of volume greater for olive oil or less for olive oil than water? So first we have to figure out the ratio. So we have weight over volume of olive oil. is equal to 5, I did that backwards, 38 over 5. So 38 pounds per 5 gallons. So how are we going to compare that to water? Because we have water up there and we have olive oil right here. So we could turn that into decimal, or why don't we just turn those into decimals? Okay. So 417 divided by 50, and then we have 38 divided by 5. So we can't really compare those unless we convert to fractions, which we're going to do in a second. So water is 8.534, and 38 divided by 5 is 7.6. So water is greater than oil. Okay, let's keep going. How much would 50 gallons of olive oil weigh? We know how much 1 gallon of olive oil weighs, right? So 1 gallon equals 7.6 pounds. So what can we do to get 50? We can just simply multiply 7.6 pounds times 50. So 7.6 times 50 equals 380. I'm going to go ahead and erase this gallons because that's not. Okay. So I want you to notice something. What I found right here in A, right here and there, is the unit rate. So you don't have to write that, but I want you to remember it. So we were comparing unit rates there. That is the weirdest E I've ever seen in my life. All right, so this is going to be really important when we come to our next topic, which is speed, okay? So speed actually follows the same proportional relationship as most things that we're going to be looking at. But we're going to look at the concept of a constant speed. So we're not getting slower, we're not getting faster, we're driving at a constant speed. And the ratio of the distance an object travels to the time. So we're looking the distance an object travels to the time is known as the speed of an object. So if d is the distance, t is the time it's been traveling. Then speed is distance over time. So if we think about it, if we go back here and look at our dependent and independent, let's look at that. Y over x equals k. So speed is our constant. Our distance would be our y, and our time would be our x. Okay? All right, so we are going to look at a couple of problems that have to do with speed. So exercise 3 says a car moving at a constant speed has a distance given by the equation. Distance equals 54t, where t is the time the car has traveled in hours and d it has traveled in miles. How far will the car travel in 3 hours? Okay, so I'm going to use the formula they gave me, d equals 54t. So d equals 54 times times 3. So the distance my car traveled is 162. And this is miles. Going miles. What is the car's speed? Okay, so we're given a formula, d equals 54t. If we look at our formula, the second one right here, it says d equals speed times time. So we don't really have to do anything but look at our formula here. Where is speed in that formula? I have d, I have t, the speed is 54. But we don't ever just say speed in a number. We have to look at the actual units. So I have hours and miles. Whenever we talk about speed, it's always distance, which in this case is miles over time. So miles per hour. So we can figure out any distance traveled or any time traveled just knowing the speed the car is going. Okay, let's look at exercise 4. Another car is moving such that the relationship between its distance and time is shown in this graph. Okay, give an estimate for the speed of the car. Okay, so whenever you're looking at graphs, you need to choose like somewhere on the graph where it looks like it's going through somewhere it meets, like through the crosses of an X and a Y. So our X is time in hours and our Y is distance in miles. So this one looks like we have gone 200 miles in approximately 3 hours. So 200 miles in 3 hours. And what we're going to do is we're going to try to find the approximation of it in 1 hour. So we have to divide 200 divided by 3. It's about, if I round it to the nearest whole number, 67 miles per hour. So the question is the car moving faster or slower than the one from exercise 3? All right, should have done faster because 67 miles is longer than 54 miles in an hour. All right, so let's go to the last one. Wright Trinity runs 147 meters in 35 seconds. So notice we have different units this time. It's meters and seconds. Assuming her speed is constant, write an equation for Trinity's distance d in terms of the time she has been running t. Okay, so we always want to look at t as being a single unit. So what we need to find is the k. So k, or our speed, is going to be d over t. So the distance is 147 meters in 35 seconds. We're going to have to do an approximation for this one again. Oh, no, we're not. So you can round to the nearest. It doesn't even, you don't even have to round. It is 4.2 meters per second. So how would we write that in terms of d? Well, let's go back up here. I have d equals speed times time. Okay, so we're going to keep d and t as variables. And now that we know k, or the speed, is d equals 4.2 t. So you're probably going to have to use that. Set up and solve an equation for how long it will take Trinity to run a kilometer round to the nearest second. Okay, so 1 kilometer is not in our equation. We have meters, so you have to do a conversion. So 1 kilometer equals, kilo means 1,000, is 1,000 meters. So I have the distance and I have the speed. So let me set that up. Distance, 1,000 meters, equals the speed, 4.2 meters per second, times the time. So I need to isolate the variable t. So you need to isolate that right here. So both sides I'm going to divide by 4.2. So 1,000 divided by 4.2 is about 238 seconds. Okay. All right, so you have Delta Math. It's Proportional Reasoning Part 2, and that should be on your checklist for today. All right.